Hello and welcome to our presentation on equilibrium and solubility. My name is Neda Mary and this is my friend Nikki Karkala. Today we're going to do an experiment on equilibrium and solubility. Let's get started. Okay. We will use a salt lead chloride to explain this. This is the reaction that we would write to show this as salt dissolves in water. We use a term called the solubility product constant. To explain how soluble the salt is in water. For lead chloride, the solubility product constant looks like this. We looked up the value of KSP for lead in several textbooks and we got 2.4 times 10 to the negative fourth. As we can see from its negative fourth exponent, it's a very, very small number. This is really small, which means that it's not very soluble in water. And so we're not going to get a very concentrated solution. If the product of the molar concentrations of lead and chloride is smaller than 2.4, then we will know that we will not see any solids in our solution. We will show this by mixing these two contents of this graduated cylinder of lead ions with the contents of this graduated cylinder of chloride ions. Notice that there is no precipitate. That is because the product of these concentrations, which we call the product quotient, which is here, is less than 2.4 times 10 to the negative fourth, which is our solubility constant number. When the two solutions are mixed, each ion is present in a 0.05 molar concentration. Now let's increase this concentration to 10th molar with these two. Now, when we mix the two solutions, we do see a precipitate. That is because the product quotient is 1 times 10 to the negative third, which is greater than our KSP. Notice the precipitate. We exceed the concentration of ions needed to make a saturated solution. The excess precipitates out as the reaction shifts towards the left, which we can see. This shifts over to the left of the equation, which we can see from our double arrows. Let's go back to our unsaturated solution, where we're going to add some hydrochloric acid. This solution contains chloride ions, which we are going to be adding right now to our solution. Adding additional chloride ions causes the product quotient to be greater than the KSP. This causes the reaction to shift again towards the left until equilibrium is re-established. Notice the solid lead chloride precipitates out. This is called the common ion effect. Now let's go back and summarize some of the things that we learned today.